Hi, my name is Lisa Oshita. I'm a fourth year statistics major at Cal Poly in San Luis Obispo, and this past summer I participated in a research program offered through the statistics program here at Poly. So for my research, I used survival analysis techniques to analyze data from iFixit's online question and answer forum. So a little bit about iFixit. It's a company that was founded in 2003 by two engineering students here at Poly. And what they do is they teach people how to fix their own devices by providing over 30,000 free repair guides and also by selling some of the specialized tools or the parts that they might need for such repairs. And another important part of their company is their online question and answer forum. So on this forum, anyone can ask a question and anyone can answer, and all questions are related to the repair of devices. So here I have a screenshot of a question and it's answered. And my job for this summer was to develop a Cox proportional hazards model to predict the survival probability of a question posted on this forum. And survival probability is defined as the probability that a certain question on this forum remains unanswered before a certain time. And the data that I worked with contained almost 8,000 questions posted between April 8th and July 7th of this year, and 63.8% of those questions received an answer by the download date. The distribution that I have on the left is the distribution of those answer times, and the curve on the right is the Kaplan-Meier estimated survival curve for all questions in the dataset, and that's just the estimated survival probabilities. And the dotted line on that graph represents the median survival time, and that's the time at which 50% of the questions in the data received an answer, which was about 9.16 hours. So to make the model, I used text mining and string manipulation techniques, or to make most of the variables, I used that. And so what I did was I extracted information from elements of the questions. And to build the model, I used fivefold cross-validation. So essentially, I built the model on each of the training data sets and used that model along with its coefficients to predict on the test data sets. And with each iteration, I assessed performance metrics to quantify how well the model was predicting. And I also ended up stratifying on the time of day that a question was posted and included splines on some of the quantitative variables. So the final model that I came to had 19 variables. Overall, it was significant, though it did have a low R-square value. As for individual predictors, there were several that were significant. Here I've only included the interpretations of a couple. So in a Cox proportional hazards model, coefficients represent hazard, and that's kind of a tricky concept, but it's roughly equivalent to the conditional probability that the event will happen in the next moment in time, given that it hasn't already happened. So in this case, we can say that the hazard is the probability that a question will receive an answer in the next moment in time, given that it hasn't already been answered. So with that, for Apple products, the hazard of receiving an answer is 155% higher for questions pertaining to Apple products than the hazard for questions about Android and other phones, controlling for other predictors. So that's saying that it's better to ask a question about Apple products if you want to receive an answer faster. And another significant predictor was whether or not the title ended in a question mark. So the interpretation is that the estimated hazard of receiving an answer is 31.3% higher for questions with titles that end in a question mark than for those without, controlling for other predictors. So that's also saying that it's better to phrase your question's title in the form of a question if you want to receive an answer faster. As for the limitations of this model, it had pretty low predictive power. And also, if I were to do this again, I would try to find a way to incorporate more quantitative variables, as the majority of the ones I used were categorical. And also, I struggled a lot with inconsistencies in the data. There aren't really any strict rules defining how a question should be asked. So a lot of users incorrectly use the tagging system or didn't define the name of their device correctly, like the examples on the screen. So these inconsistencies made it kind of difficult to work with the data. So the suggestion that I have for that is to just include more guidelines and instructions on the page where users can ask a question. And with that, I'd like to thank Dr. Shannon Pileggi, my professor and research advisor, and also Anthony Pileggi, the data scientist at iFixit and my industry advisor, and also Bill and Linda Frost for funding this research. So yeah, that sums up my research, and thank you for watching.